Hi, today we're going to be working on Lesson 12, Session 2. We will be adding fractions with unlike denominators. Today we're really going to focus on developing strategies to do that, to add those fractions with unlike denominators. We'll be working in our Ready Classroom math workbook. We'll be on pages 231 through 236. So go ahead and turn your math book to page 231. So on page 231, this is the problem that we see. It says, Maggie paddles her kayak 1/2 of a mile to an island. Then she paddles 4/5 of a mile to a beach. How far does Maggie paddle her kayak in all? So first of all, what is this problem talking about? And it's talking about Maggie, who's paddling her kayak. What problem are we trying to solve? We are trying to see how far does Maggie paddle her kayak in all? And then what is the important information? The important information is she paddles 1/2 a mile to an island and 4/5 of a mile to a beach. So if we were going to do this, I'm going to teach you a strategy today of how to add two fractions with an uncommon denominator. So unlike other days, I'm not going to have you pause the video and try and figure it out for yourself. I'm going to actually show you the strategy that I think will be helpful if I can get it to autofocus. We'll see if we can get it to go. If not, I will make it work. All right, there we go. So when we are adding two fractions, this is the equation we're trying to solve right now. What is 1/2 plus 4/5? Now, right now, we can't add those together because the 2 and the 5, the two denominators, they are not the same. In order to add these two fractions, we need to make these denominators the same. So the first thing you're going to do is you're going to write the two fractions in sandwich formation. That means you're going to write them on top of each other because it's easier to work when the two fractions are written going up and down because we're going to be making these into equivalent fractions. Next, we need to figure out what is our lowest common multiple, meaning what is the smallest multiple that both 2 and 5 have in common. So to do this, we're going to find all the multiples of 2, and then, or going up about, we'll go up 5 or 6 multiples, and then we're going to find the multiples of 5. So let's start with the multiples of 2. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. 2 times 6 is 12. And then we'll stop there. Now we're going to do multiples of 5. If we get to a multiple that we have in common, we can stop because we know that we found our lowest common multiple. This is our lowest common multiple. That's where we get the LCM. So 5 times 1 is 5. 5 times 2 is 10. Now, if you were here in person, the whole class would go, stop, because we can stop. We have found our lowest common multiple. It is 10. 2 and 5 both have a multiple of 10. That is going to be our new denominator. So we're going to come over to our sandwich formation and we're going to write in our denominators of 10. If you want, you can even put your denominator in your answer because when we add fractions, the denominator stays the same. So we're going to put our lowest common multiple as the denominator of our soon-to-be equivalent fractions. After we found the lowest common multiple, Then we need to make equivalent fractions. Now, to make equivalent fractions, what we're going to do is we're going to look first at this 1/2. We need to figure out how many times did we multiply 2 to get this 10. So I know that we multiply 2 times 5, that equals 10. So now, whatever we multiply the denominator by, we also multiply the numerator by. Otherwise, we have to multiply in one fraction, we have to multiply them both by the same number to keep the fraction equivalent. So 1 times 5 is 5. So 1/2 is the same as 5/10. And we know this because actually 5 is half of 10. So now we're going to try and find an equivalent fraction for 4/5. So what do we multiply 5 by to get 10? That's right, we multiply it by 2. 5 times 2 equals 10. So if we multiply the 5 times 2, we also have to multiply the 4 times 2. So 4 times 2 is 8. So 4/5 is equivalent to 8/10. Now that we have equivalent and we have the same equal or the same we have common denominators, now we can add our two numerators. So we can add 5 plus 8 equals 13. And then that 13 comes down to our answer, and our answer is 13/10. Now we can leave that. Right now, what we see is what is called a improper fraction because our numerator is larger than our denominator. We're going to go ahead and leave it alone right now, but I will show you on the next page how we can change this number into a mixed number. So this 13/10 is our answer. So what is 1/2 plus 4/5? Believe it or not, it is 13/10. So I want to go over those steps one more time with a different equation that I've already written out so that you can understand all of the steps of how we can add fractions with uncommon denominators. So if I'm looking at the equation 1/4 plus 1/6, I want to figure out how to solve that. So the first thing that I do is I write the equation in sandwich formation. So here I wrote my 1/4 and my 1/6. Next, I'm going to find the lowest common multiple, which is referred to often as the LCM, meaning lowest common multiple. You might also hear it called the LCD, which is the lowest common denominator. When you see both of these, they both are the same thing. That's what we're looking for. We're trying to find the smallest number or the lowest number that are both multiples of 6 and of 4. So first we will write the multiples of 4. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, and 4 times 5 is 20. Then we're going to find the multiples of 6 until we find a common multiple. 6 times 1 is 6, 6 times 2 is 12. We can stop at 12 because we know that 12 is a common multiple between 4 and 6. It's a multiple that they both have in common. So we're going to write that common multiple as our denominator in our answer and then also in our two soon-to-be equivalent fractions. Our third step is to make equivalent fractions for both fractions. Remember that we're really thinking about each fraction as its own part. We find equivalent fractions for each one separately. So 1/4, what do we multiply 4 by to get 12? We multiply it by 3. So 4 times 3 is 12. 1 times 3 is 3. Remember that we multiply the numerator and the denominator by the same number to keep them equivalent fractions. Then we're going to go, and then I showed that up here as well. So so we are going to next, I found the equivalent fraction here. Sorry, somebody just stepped in the classroom. Now I'm going to find the equivalent fraction for 1/6. So what do I multiply 6 by to get to 12? I multiply it by 2. 6 times 2 is 12. 1 times 2 is 2. Remember that you multiply by the same amount on numerator and denominator. I showed that up here as well. You don't normally have to do this step. You can do all the work up here. So then now I have my equivalent fractions. 1/4 is the same as 3/12. 1/6 is the same as 2/12. So finally, after I found my equivalent fractions, then I'm going to add my equivalent fractions, keeping the same denominator and adding the numerators. So 3/12 plus 2/12 equals 5/12. This will also be available to you in poster form if you need to remember the steps for adding fractions with uncommon denominators. So now let's go ahead and turn to page 232. On page 232, we actually see two different methods of how we can multiply, or excuse me, how we can add the fractions 1/2 and 4/5. So you can picture the fractions in the problem using fraction bars. The fraction bars are divided into halves and fifths. So the island is 1/2 of a mile. That's how far she biked to the island. And then she biked 4/5 of a mile to the beach. So we see how much she biked to the island and how much she biked to the beach. Now, in order to add these together, both fraction bars need to be divided into the same size parts. So we know that we need to divide both of these fractions into 10 parts. So if you see these tiny little dotted lines, each of those are making the island fraction bar into 10 parts, and the beach fraction bar also into 10 parts. Now, all we have to do is count how many of those parts we have to create our equivalent fraction. So we see here that the island is 5/10 of a mile, and the beach is 8/10 of a mile. So 1/2 is equivalent, or this 5/10 is an equivalent fraction to 1/2. And 8/10 is an equivalent fraction to 4/5. So now, because we have equivalent fractions, we can now add them together. When we add them together, we get 13/10 because 5 plus 8 is 13, and then we keep the same denominator because the number of parts in one whole does not change. You can also model the problem with an equation. So as you can see, this is what I showed you. They wrote the two fractions in sandwich formation. They then multiplied each fraction by a number to make an equivalent fraction where the denominator is both 10. And then they added together the two numerators. So 1/2 plus 4/5 equals 5/10 plus 8/10. The only difference I did is I added them in sandwich formation instead of adding them next to each other. But as you can see, you add the 5 and the 8 and you get 13/10. So either way you solve the problem, you're still going to get the same result. You're still going to get the same fractional part. Okay, go ahead and go to page 233. On page 233, the first question asks us, explain why both fraction bars in picture A are divided into 10 equal pieces. So why did we have to divide these into 10 equal pieces? The reason we had to do that was because 10 is a multiple of both 2 and 5. So dividing each whole into 10 equal pieces allows you to group the pieces together. We cannot group pieces together that are not of equal size. So we can't just add this one piece to these 4 pieces because this one piece here is not equivalent or equal, this one piece here is not equal to the pieces here. So you can't just add them together. That's why we had to make them both into 10 equal parts in order to add them together. So What was the total distance Maggie paddled as a fraction of miles? We know over here that she paddled 13 tenths. Now, write the total distance Maggie paddles as a mixed number. So I promised you I would show you how to make this into a mixed number. If we have 13 tenths, we know that that is the same as, we know that it takes 10 tenths to make one whole. So that is the same as 10 tenths plus 3 tenths, because 10 plus 3 is 13. And then we have, in this case, common denominators, so we could add the 10 tenths and the 3 tenths together. Now, what whole number makes 10 tenths? That's right, 1 whole plus 3 tenths is the same as 13 tenths, or the answer is 1 and 3 tenths. So the total distance Maggie paddled as a mixed number is 1 and 3 tenths. We just broke up this 13 tenths into 10 tenths and 3 tenths. So we know we have 1 whole and 3 tenths. So now, looking at the denominators in Model It, so if we're looking at the denominators over here in Model It, the denominators down here, the 10 and the 10, it says, what do you notice about the relationship between the original denominators, 2 and 5, and the common denominator of 10? So what is interesting about the denominators 2 and 5 and the two denominators of 10? And the key is to look here and here. What do you notice? Well, I notice that the common denominator is the product of 2 times 5. 2 times 5 equals 10. So sometimes you one way to find the common denominator when you're trying to find a common denominator between two fractions is simply to multiply the two denominators times each other to make the common denominator. It won't always be the lowest common denominator, but it will always be a common denominator. So, is 10 the only common denominator for 2 and 5? Justify your answer. So the answer is no, 2 is not the only common denominator. If I were to write out multiples of 2 all the way up to 30, I would just go 2 times 1, 2 times 2, 2 times 3, 2 times 4, and keep going all the way on until I get, in this case, 2 times 15. Then, if I find the multiples of 5, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, I could keep going on and on forever. Now, as you can see, just going up to 30, I find that 2 and 5 have common multiples of 10, of 20, of 30. So it looks like every multiple of 10 is a common denominator between 2 and 5. The reason that we try to find the lowest common multiple is because having the lowest, it's going to give us the smallest numbers to work with. The bigger the common multiple, the bigger the numbers are that we're working with. So we always try to find the lowest common multiple. So number 5 now says, explain how to add two fractions with unlike denominators. So here's what we do. This is in word form what I did in this picture here. So first you find a common denominator of the two fractions and then make equivalent fractions. So we need to find the lowest common multiple, or any common denominator, but it helps to find the lowest, of two fractions. And then make equivalent fractions. Then add the equivalent fractions together. Remember, one way to find a common denominator for two fractions is to multiply their denominators. So after you write that down, I want you to reflect back on the two strategies we practiced today. We practiced using a fraction bar, and we practiced using equations to add fractions with unlike denominators. So when adding fractions with unlike denominators, the strategy I like best is, and then tell me either fraction bars or equations, and then say because, and then tell me why you prefer that strategy. Go ahead and pause the video and fill that out now. All right, let's go to page 234. We're going to practice 3 problems. I'm going to do 1 using the fraction bar method, and then I'm going to do 2 using the equation method. So Hank practices 5/8 of the words on his spelling list on Monday. He practices another 1/4 of his list on Tuesday. What fraction of his spelling list has Hank practiced so far? Show your work. So first, what are we talking about? We're talking about Hank practicing his spelling list. What is the problem we're trying to solve? What fraction of his spelling list has Hank practiced so far? What is the important information? We know that he practices 5/8 of the words on his spelling list on Monday, and he practices 1/4 of the list on Tuesday. So we want to add those 2 together, but we can't add them together right now because they are not equal parts. Let's look at the 2 fraction bars to see that. So 5/8, let's fill in 5/8. That's 1/8, 2/8, 3/8, 4/8, and 5/8. Now we're going to add to that 1/4. So 1/4 would be 1 of the 4 sections that I colored in. Now we're going to see, okay, how can I make these 2 have a common denominator? So one thing that I always like to see is I like to look at the lower number and see the lower denominator, not the bottom one, but the number that is less, the lesser, that's a better word, the lesser denominator, to see if the higher denominator is a multiple of the lesser. And in this case, I know that 4 times 2 is 8. So that tells me I can actually leave the 5/8 alone. And I just need to find a equivalent fraction of 1/4 to make it into an 8th. So if I were to do that, if I multiplied this 4 times 2, I would get 8. So I'm going to go ahead and multiply this numerator times 2 and get 2 times 1 is 2. So 2/8 is equivalent to 1/4. So if I wanted to take this bar and break it into eighths, I can see that I have 2/8 shaded in. So now I can add 5/8 plus 2/8 because I have 1, 2, 3, 4, 4, 5, and then here I have 1, 2. So 5/8 plus 2/8 equals 7/8. Because remember, the denominator stays the same, you just add the numerators. So Hank has practiced his spelling list 7/8. He has practiced 7/8 of his spelling list. That is using the fraction bar method. Now we're going to do number 8 using the equation method. So remember, the first thing we do is we write our 2 fractions in sandwich formation. 7/6 plus 5/8. Then we need to find what is our lowest common multiple, our LCM. So we need to find the multiples of 6 and the multiples of 8. So the multiples of 6 are 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, 6 times 5 is 30. I think we'll find it if I stop there. If you do not know your multiples, you can always pull out your multiplication chart and just simply write down all of the multiples from the multiplication chart in order. Now let's do our 8s. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. And I see there I can stop because the multiple 24 is a multiple of both 6 and 8. So now I can put our new multiples as being 24, our new denominators as being 24. Now, what number do I multiply 6 by to get 24? I multiply it by 4. So remember, whatever I multiply the denominator by, I also multiply the numerator by. 7 times 4 is 28. Then I'm now going to find out, what do I multiply 8 by to get 24? Well, I multiply 8 times 3. So if I multiply the 8 times 3, I have to multiply the 5 times 3 as well. 5 times 3 is 15. So now that I have common denominators, all I need to do is add my two numerators together. 28 plus 15. I happen to know that that is 43. So I'm going to write that as 43. And then my answer is 43 over 24, because 24, the denominator stays the same, and my numerator is 43. Now we have an improper fraction. Remember, an improper fraction is any time the numerator is larger than the denominator. So we can change this into a mixed number. To do that, I'm going to do that over here so that I have room. We have 43 over 24. That is the same as 24 over 24 plus what over 24? So if we subtract 24 from 43, we're going to get 19. So don't worry, 24 24ths plus 19 24ths still equals 43 24ths. The way that I got this 24 and this 19 is I wanted to make sure I had one whole, so I made 24 24ths. Then I said, what is 43 minus 24? It's 19. So that's my remaining parts. So then I have 19 24ths here. So my answer is 1 whole and 19 24ths, or 1 and 19 24ths. All right, let's do we'll add 2/3 and 5/12 using the equation method again. So we write it in sandwich formation, 2/3 plus 5/12. Now remember, I told you I like to look at the lesser denominator and see if the greater or the larger denominator or greater denominator is a multiple of 3. And in this case, it is, because we know that 3 times 4 is 12. So therefore, we don't need to change 5/12 because 5/12 can stay the same. We just need to change 2/3 into an equivalent fraction so that we can add the two fractions. So if we're going to make 2/3 into 12ths, I know that 3 times 4 is 12, and 2 times 4 is 8, remembering to multiply them both by the same amount. We don't need to do anything. Technically, we're multiplying it by 1 if you want to write something there so that you have something there. But we don't need to change it because 12 is 5/12 is already written in a equivalent fraction that we can add where the two have the same denominator. So now we're going to go ahead and add our 8/12 to our 5/12. So we just add our two numerators. 8 plus 5 is 13. Our answer is 13/12. So then that means our answer is C. Now, I know that that was a lot of new learning for today. So please, 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 if you have any questions, email your teacher. Otherwise, you're going to go ahead and move on to pages 235 and 236 to do some practice on your own. If you have any questions, like I said, email your teacher. Otherwise, I'll see you next time.